Hello friends, welcome to my YouTube channel Spiral Learning. So today we will discuss it, a chapter. This is chapter 2 from class 11 physics. Name of the chapter is Units and Measurement. In this discussion we will cover the following topics. First one is concept of physical quantity. The second one is concepts of units, and the third one is concept of SI unit. Fourth one is fundamental and derived units. Fifth one is significant figures, and the last one, that is the sixth one, is importance of significant figure. These six topics of the chapter are very important for the examination perspectives and also important for the further studies of your life. So let's start. In the slide we will explain the concepts of physical quantity. So what is physical quantity? First of all, you should know this fact: all the quantities which are used to describe the laws of physics are called physical quantities. Example: length, mass, volume, etc. are considered as physical quantities. Actually, any measurable quantity is called a physical quantity. Here we are considering the length of a rod. Suppose the name of the rod is AB, and the length of the rod is considered as 10 meter. Okay, so the length of the rod is a measurable quantity and its length is 10 meter, and we are considering the volume of a cylinder, and the volume of the cylinder is, as for example, 15 meter cube. So it's a measurable physical quantity. Now we are considering the mass of a sphere, and suppose the mass of the sphere is, it's a solid sphere, let us consider, is 5 kg. So this is also a measurable physical quantities. So the quantities which can be measured are called physical quantities. Okay, so let us consider another example. We are considering a lamp post. Okay, the lamp post is hung from a certain height. So the length of the lamp post is, as for example, 15 meter from the ground. So it's a measurable physical quantity. So it is a physical quantity. Okay, then physical quantities are of two types. First one is fundamental physical quantities, which are independent of other physical quantities, and second one is derived quantities, which can be derived from the fundamental quantities. So physical quantities are basically two types. Physical quantities are of two types. First one is fundamental physical quantity, we can write FQ, and the second one is derived physical quantity. Okay, derived quantity depends on fundamental physical quantity, but fundamental physical quantities are independent. Okay, independent. Next, concepts of SI unit. So first of all, we should know what is unit. Measurement of any physical quantity involves comparison with a suitable basic arbitrarily chosen internationally accepted reference standard called unit. Okay, so it should be well accepted by the international bodies or national bodies. Okay, second, the units which are used to represent fundamental quantities are called fundamental or base units. However, the unit of derived quantities which are represented in terms of fundamental quantities are called derived units. Okay, then some of the commonly used system of units for measurement which with the base units for length, mass and time are given as first one is CGS unit system, here C for centimeter, G for gram, S for second. Centimeter involves the measurement of length, gram involves for the measurement of mass and second involves for the measurement of time. Likewise, in FPS system, for the measurement of length we are using foot, for the measurement of mass we are using pound, and for the measurement of time here we also using second. Okay, and in MKS system we are using for the measurement of length meter, for the measurement of mass kilogram, and here also for the measurement of time it is second. Okay, so second is common for all the system of units. Okay, so it's a very important thing. Second involves in all this system of units. Okay, so we are considering here the units. Now we are considering the concept of SI units. Okay, the system of units which is at present internationally accepted for measurement is the International System of Units. This system contains 7 fundamental units and 2 supplementary units which are tabulated as below. First one is length, second one is mass, third one is time, fourth one is electric current, fifth one is temperature, sixth one is luminous intensity, and the seventh one is amount of substance. Okay, so what is the fundamental unit of length? This is meter. What is the fundamental unit of mass? This is kilogram. Fundamental unit of time in SI system, it is second. Electric current, it is ampere according to the name of the scientist, and this is Kelvin, it is also from the name of the scientist. Luminous intensity, it is candela, and amount of substance, this is mole. Meter is represented with the symbol of small m. Kilogram, which is represented with the small of small k and small g. Second is represented with the help of a small s, small letter s, but current ampere is represented with a capital M, as it is taken from the name of a scientist. Kelvin, it is also represented with a capital letter because it is also taken from the name of a scientist. Then candela is represented as CD, where C and D both are small. Mole is represented as MOL, mole, molar, in small letter. Now there are 2 supplementary units. First one is plane angle, second one is solid angle. Plane 1, plane angle is the unit of plane angle is radian in SI system obviously, and the unit of solid angle is steradian. Radian is symbolized by RAD, red, colored in small letter. Steradian is symbolized as S and R, SR. Okay, all are in small letter. So let us draw a plane angle. Let us consider a triangle. Name of the triangle is ABC. So we are considering this angle and the angle is theta. So you can say it's theta radian. Okay. But if you are considering the angle of a cone like this, now we are considering this angle. So it is in steradian. This is a plane angle. Okay. Now it is clear to you, plane angle and solid angle and the 7 fundamental units of SI system. These are very, very important for your whole life. Okay. Now fundamental units. How we can define fundamental units? So here fundamental units, also known as base unit, are the basic and independent units of measurement for physical quantities. Okay, we previously said that all quantities that are measurable are called physical quantities. So here written this one is, they cannot be derived from other units from the fundamental foundation of the entire measurement. Okay, they cannot be derived from other units, and these fundamental physical quantities form the foundation of the entire measurement. Okay, the International System of Units, that is SI, defines 7 fundamental units, each corresponds to a basic physical quantity. That is, meter, it is a fundamental physical quantity. Kilogram, it is also a fundamental unit which represents a fundamental physical quantity which is mass. Meter represents another fundamental physical quantity which is length. Second represents the fundamental quantity time. Ampere represents the fundamental quantity current. Kelvin represents the fundamental quantity temperature, and mole represents the fundamental quantity amount of substance. Candela represents luminous intensity. So these are the 7 fundamental physical quantities which are represented by different base units. Okay, and these are the base units. Okay, so we are now know all the base units of SI system. Okay, derived units. So derived units are depends on fundamental units. Derived units are units that are derived from fundamental units using mathematical relationship. These are used to measure the physical quantities that are combined of base quantities like velocity, force, energy. Okay, here velocity, force, energy, pressure, these are explained how these are related with the base units. So let us elaborate the concept here. First of all, we are considering velocity. Velocity is represented as displacement by time taken. Okay, time taken. Displacement is represented in SI system in meter unit, and time is represented in second. So the derived unit of velocity in SI system is meter per second, or we can write meter s to the power minus 1. Likewise, if we are considering the SI unit of acceleration, it becomes acceleration equal to velocity by time taken. Okay, velocity is meter per second or meter s to the power minus 1, and then here second. So we can write m s to the power minus 2. Okay, or we can write meter per second square. Now force equal to mass into acceleration. Okay, acceleration is represented as a mass into acceleration. Mass, the unit of mass is kg, and the unit of acceleration is meter per second square, or we can express it as kg meter s to the power minus 2. So this is basically represented as Newton, okay, according to the name of the scientist. Now energy is measured in terms of work done. The work done equal to force into displacement. Suppose d is the displacement and f is the force. The unit of force is Newton. In SI system, displacement is meter. So this is Newton meter. Okay, and we can say, according to the name of the scientist, the unit of energy is joule. Okay, then pressure equal to force by area. The unit of force, as you know, it's Newton, and then it's meter square. So it's Newton per meter square, or according to the name of the scientist, we can say it is Pascal. P is in capital letter. That's all. Now, significant figures. Significant figures are very, very important in the study of physics as well as in the study of chemistry. Okay, significant figures, or you can say significant digits, are the digits in a number that contribute to its precision, indicating which numbers are meaningful in expressing the value of a measurement. They help reflects the accuracy, reliability of measurement in a scientific calculation. Okay, now the key rules for identifying the significant figures. First one, non-zero digits are always significant. Example, 1, 2, 3, 123, here 3 significant figures. Another, non-zeros between non-zero digits are significant. Here is a 0 between two non-zero numbers or digits. So here the significant figure is 4. The third key rule is leading zeros. Leading zeros means zeros before the first non-zero digit are not significant. Okay, example, these 3 digits are not significant, only these 2 numbers, that is 2 and 5, that is there are 2 significant figures. Fourth key rule, trailing these zeros in a number with a decimal point are significant. Okay, so after a decimal point, this is a decimal point. After the decimal point, this 0 and this 0 is considered as significant figure. So there are three significant figures. In this example, this 0 is not considered a significant figure, so there are four significant figures. Okay. Next, the fifth one. Trailing zeros in a whole number without a decimal point are ambiguous. Why it is written as? We will answer that here. 5,000 could have 1, 2, 3, 4 significant figures depending on the context. To clarify scientific notion is often used 5.00 into 10 to the power 3. So in this case there are three significant figures. This is not a significant figure. Okay, in the next slide we will understand it's little more. Okay, now importance of significant figure. Why significant figures are necessary? It is necessary for the accuracy. Okay, significant figures indicates how precise a measurement is. Okay, the more significant figures, the more accurate the measurement. Then the rounding. When performing calculation, the final answer should not have more significant figures than the least precise measurement used in a calculation. What does it mean? Suppose we are calculating the volume of a rectangular parallelepiped. Okay, so the length is 5.23 centimeter. Here are three digits. The breadth is 2.3 centimeter and the height is 12.932 centimeter. So here are least significant figure is 2.3. Okay, so in the last calculation of the volume, the result should be contained at least two significant figure. Okay, fine. Then example 45.67 has four significant figure and 0.00340 has three significant figures. Here these two zeros are not, this one also are not significant figure, ignoring leading zeros. Okay, now the last example that we considered in our previous slide, 1200. Here two significant figures if we write it in this manner, but unless writing this way, here the significant figures are 4. This is not a significant figure. So we are writing it in a manner that it's clarify the concept. So depends on the concept which we are going to explain. Okay, so significant figure is necessary for the accuracy of measurement, another thing for the precision as well as for the reliability behind it. Okay, now significant figures are crucial in science, engineering because they convey the precision of measurement and calculation clarity. Okay, thanks for watching the video. In the next session, the dimension of the physical quantity will be discussed. Thanks once again.